Let's go ahead and label some of the stuff. Remember, origin is where? Right there. It's the coordinate 0, 0, right in the middle. Where is the x-axis? Where is the y-axis? That's negative, comma, positive. So all these are the negative x's, negative 2, comma, positive 3, negative 1, comma, positive 7, quadrant 3. Four. Is that right? Yeah. So quadrant 4. X's are positive because we're right of the y-axis, and then y's are negative. And we do know up and down means vertical, right? And horizontal left and right, straight. Just a good reminder. Recall how to plot points. Where's 1, 5? What quadrant? And where is it? 1 positive, 5 positive, right here. 1, 5, and label it. 1, negative 2.5. 1, negative 2. What quadrant is this? 4. 4, good. 0, 3. 0, don't go left or right. Comma, negative 3. What quadrant is this? Not in a quadrant. So if there is a 0, x or y or both, it's not a quadrant. It's on an axis. So a point can be located in 2 categories, either on an axis or a quadrant. And when you have a 0, you're on an axis but not in a quadrant. Negative 4, 6. There. All right. Negative 4, to the left, comma 6. Good. Good reminder. Go ahead and try this one. Just sketch it out. Doesn't have to be perfectly straight, but in general, get the quadrants all correct. Give that a shot. So we have, let's see, 3, 4. 2, negative 2. 5.5, 0. On an axis, not on a coordinate. Negative 3, negative 6. Quadrant 3. And 0, 1. Not on a quadrant. Good. Not too bad, not too bad. Now, we will be getting into slope, so you guys remember, hopefully, about counting rise over run, like just to get from one place to another, how much you have to go up, how much you need to go to the right. So we'd say that from 1 to 4, that would be 3, and from 0 to 3, that would be 3. So the slope would be 3 over 3, or just 1 over 1. It means you just have to go up 1 over 1, up 1 over 1, up 1 over 1. Make a line. That's what we'll be diving into today. You're going to be given some graphs. Just have to identify the slope. You guys might remember slope too. We're not going to go through that journey again. However, okay, there are 4 different types of slope. And we got the positive, because it's going uphill. It's like a skier, so they're saying, I think this was puff, puff, positive. Remember that? Because he's huffing and puffing trying to go uphill. And then he said, what was downhill?
Nice, negative.
Nice, negative. And then we have zero slope, zero fun, not going up, not going down. And then undefined, yes, vertical, undefined. Just to go into these two, remember when 0 is on top, okay, that's when it's okay. So think of this, 0 on top is okay. That means it equals 0. When 0 is on the bottom, that's how you get undefined. When there's no run, only rise. Okay. 0 is on the bottom, that's no good. Okay. NO. 0 on the bottom, no, undefined. It's impossible to divide by 0 in mathematics. The only way we get close to dividing by 0 in math is calculus. Okay. So all math leads up to calculus. Once you get to calculus, we can find a way, kind of a loophole around dividing by 0. So those are the few. So real fast here. Is that positive or negative? Positive. Negative. No, 0. Undefined. There we go. So you see, the first thing you know is the sign of the answer. The first thing you want to do is figure out, is it positive, is it negative, is it 0, or undefined? If it's 0 and defined, there's no work to show. If it's positive or negative, well, at least before you start, you know the answer is positive or negative. So here we can say the positive. Find 2 points. Here I give them to you. They're right here. What's the rise? All right. 1, 2, 3, 4, 5. Positive 5 over 1, or just 5. Not too bad. Okay. Same thing here. We already know the answer is negative. Write negative. What's the rise? 1, 2, 3, 4. The run, 1, 2, equals negative 2. Which means it's negative 2 over 1, which means we can also go up 2 over 1, up 2 over 1. Just do it twice. We could also count from here and go down. 1, 2, 3, 4. Right, down 4. And then positive 2. Of course, you can see we get the same answer. So it doesn't matter where we count from. The slope from here to here is the same as the slope from here to here. Okay? If I count, go up and left, it's the same slope if I go down and right. There's only one slope for every line. All right, you guys go. What is it? Positive or negative? Okay, and what's the rise?
Up 3.
Up 3 over?
2, 1, 1.
Up 3 over 1. Good. Next. Positive, negative? Rise of?
Negative 2 over
2 over 3. You can see it's nice. After I put the sign there, I don't have to worry about left, right, and it's positive, negative. I already have the right sign for the answer. Here it's just counting up and down, left, right. Forget about this direction of the sign. Keeps it a little easier. Here? 0. And if you had to prove this, you can pick any points. Right? What's the rise? 0. What's the run? The run would be
1.
2. And then, but 0 over anything is 0. That's why we could have picked any points here. It would have been 0 over 5 or 0 over 6. It's still 0. So that's how you can pick any points. Good. Positive or negative?
2 over 4. Positive 2 over 1.
up 2 over 4, okay, which equals a half. So we can go up 2 over 4, or if we reduce it, up 1 over 2. Up 1 over 2. So when you reduce the slope, that also has to work. Is this the same thing? Up 1 over 2, is that the same as negative 1 over negative 2? Those just cancel out, right? Does that work?
Yes.
Down 1, left 2? Yeah, same thing. If I multiply it by 2, down 2, right 4. So as long as I multiply the slope by anything, negative, positive, it still stays on the line. Good. All right, and I think that's enough of that, right? What's this again? Undefined. We can abbreviate that UND, if you like. UND. Okay. All right. Graph the points. 0, negative 2, and 1, 3. All right, here we go. 0, negative 2. Don't go left or right because it's 0. Down 2. 1, 3. Okay, start in the origin. 1 to the right. Up 3. Draw a nice straight line, straighter than mine. And then count the rise and the run. 1, 2, 3, 4, 5. 1 over 1. So that's just 5 over 1, which equals 5. Just like that. Now, what if we start at this point? Will we get the same slope?
No.
Absolutely, yes. So remember, every line has one slope. So if I went here, I'd have 1, 2, 3, 4, 5, negative 5, right? And to the left one, be negative 1. Negative 5 over negative 1 still equals positive 5. So the same thing, one line, one slope, no matter what, no matter where you start and where you finish, there's only one slope. If you ever try to count it a different way and you get a different answer, one of them's probably wrong. Good. All right, you guys sketch that out, try it on your own just to make sure. What's the special name for 0, 0 again? Origin, yes. It's the middle, it's the nexus, where everything comes from, the origin. Right. And if you're finished, try both ways. Alright, see if you can count from, if you count from 0, 0 to 3, negative 2, make sure you get the same slope if you go the other direction. No matter which side you start from, you should get the same slope. All right. Okay, so down 2, right 1, you get negative 2/3. Okay? Or you could have gone up to left 1, so left 3. Either way, the answer is negative 2/3. So whether a negative's on the top or the bottom, that's the same thing. So we get the same slope. Hopefully the first thing you came up with is that this is negative. Okay, this is definitely negative. You write the sign first, then you just count up, down, left, and right. Don't have to worry about signs. All right, good. Lastly, I'm going to have you guys practice if I just give you 2 points. Okay. So first thing is I'm going to just give you a bunch of sketches, but on the back is going to be, what if I give you 2 points? Now this is faster than you used to, because we're trying to speed through the whole first semester in 1 quarter, or doubling one. But let's give a little review on how do you find the slope without graphing. Okay. How do you find the slope without graphing? Actually, let's just stop it there. Have you guys work on the front, and then we'll get back in about 10 minutes, 15 minutes. And have you guys, all right, as I mentioned, good method. Put the sign first, Is number 1 positive or negative?
Negative.
Number 2?
Negative. I mean positive.
Number 3?
Positive.
Positive, it's going up. Number 4? Negative, it's going down. Number 5? Positive. 6? Number 7? Positive, it's going up. Here, 8? Which one is it?
0.
0. 0 slope. Number 9? Up and down is?
Undefined.
Undefined. And 10 is? Negative, going down. So you see, you should know the sign of your answer like that. Just picture something going uphill, downhill. It's always from left to right.
This homework?
Huh? Back will be homework. Then go through and count the squares. How many up? Okay. 1, 2, what is it? Up 3. Up 3. Right 3. So negative 3 over 3 is negative 1. Number 2. Go up 1, 2, 3, 4, 5. Up 5. Right, run is 1. Equals positive 5. Well, actually, there's a 5 already there. Equals 5. Alright, same thing here. Number 3. Up 1, 2, 3. Rise. Overrun. 1, 2. Positive 3 over 2. Don't have to worry about signs. I already put it there to begin with. Okay. One more. Rise is 1, 2, 3, 4, 5. Run is 1, 2, 3, 4, 5 again. Okay, yeah, so that's negative 1. Make sure you reduce these when necessary. Negative 3 over 3 is negative 1. 5 over 1 is just 5. 3 over 2 you can't reduce. Negative 5 over 5 is negative 1. Always want to reduce. Okay, good. Let's take a look at the back. Okay. Let's go to here. Okay. So I'm going to remind you of a formula. We'll go more in depth tomorrow. But for now, for each of these, how can you find how far 2 points are from each other without actually counting squares? Okay. So let's say we had a ruler, right? So ruler that this is 1 inch, 2 inch, 3 inch, 4 inches. Just using basic mathematics, how can you figure out how far is it from 1 inch to 3 inches? How do you figure out, without counting though, just using the 1 and the 3, how can I figure out how far apart they are? Yep. Add 2. Well, not 2, but, well, how far is it from 1 to 3? It's how much? 2. 2 inches, right? And how can you get the number 2 using a 1 and a 3? Yeah, 3 minus 1 is 2. So you can find out how far apart it is from two numbers by subtracting. So the same thing here. We can subtract the rise and subtract the run, and that will give you the same as if we went through and plotted the points, right, and counted squares. So instead of doing all this work, we don't have to do that, right? We just have to subtract the rise and subtract the run on the bottom. So question, what numbers represent the rise, up and down? The y values, yeah. 1 and 4. So you put 1 and 4 in here. And then the other two numbers are the run. So you put 1 and 3. and you can calculate it. So write this in, and this is the first problem on the back. Go ahead and write that in right now. 1 minus 4, negative 3. 1 minus 3, negative 2. That equals positive 3/2. Negative over negative, positive. And as you saw here, when I kind of graphed it a little bit, you can see the answer was a positive slope because it's going up. So my advice to you, you call this a skeleton, is that you write out fraction and then 2 parentheses on top and on bottom being subtracted. And then just plug in the numbers. The most common mistake, of course, is when there's negatives involved and you have a double negative. This helps prevent any mistakes with negatives. Write it out. Yeah. All right, so the y values always on top, 0 and 4. On the bottom, 0 and 5. We have negative 4 over negative 5, which is positive 4/5. And when you're doing these, if you're not quite sure, go ahead and sketch it real roughly. Like, okay, that's 0, 0. Okay, there's 5, 4. Okay, yeah, that's positive. That's going up. So my sign is correct. You can verify it pretty quickly with minimal work. Hard to do this in your head, though. Most people have very difficult time visualizing all these points, problem after problem. If you just sketch it out, you know for sure. Positives going up, though. Let's see here. So on all of these, I recommend just setting them all up to begin with. So just start off with, again, I call this a skeleton, just a bunch of empty bones. And then you just fill in all the numbers. The only mistake here is usually, do you put the y values on top and then negatives? Don't mix up negatives when you start having negatives. Okay, just do this for each problem. Colors here, and then okay, y values on top, 2 and negative 2. X values on the bottom, negative 2 and negative 1. And you can see here, double negative. Bottom, double negative. So this is 2 plus 2. That's 4. Not 2 minus 2, but 2 plus 2. And on the bottom, negative 2 plus 1. And negative 2 plus 1 is negative 1. So we get negative 4.
Wait,
Yep.
isn't the first one supposed to be negative? The 2?
It is. And no. See, it's positive 2. There, the y.
Oh, no.
This one's negative. Yeah. The second numbers go on top. Second numbers on top. 3 and 0. 3 minus 0. On the bottom are the x values. Negative 1 over negative 1. Ooh. What's the answer to 14? What does that come out to be? 3 over negative 1 plus, oh no, sorry, negative 1 minus negative 1 is negative 1 plus 1, which equals 0. So the answer is, let's graph it. What does it look like? Negative 1, 3. Negative 1, 0. What kind of line is this? Vertical. Anything over 0, it has no run. It doesn't go left or right. So therefore it's vertical. It's undefined, right? Fine. So the vocabulary here is just as important as the calculations. If we leave off or forget one little negative, this all of a sudden looks like minus 2 or something instead of 0. So if you're ever unsure, go ahead and just sketch it and see. Wait a minute, that's not positive or negative, that's vertical, that's undefined. One hint though, is that if both x's are the same, that means there's no run. It's not moving left to right if both x values are the same. If they're both -1 or they're both 5, it'd be vertical. If both y values are the same, you know there's no rise. It's 0. So there are some faster ways once you've done this enough to see what the answer is, minimal work. But until then, we'll have to calculate it all out. So finish up the back, and that will be it for your homework question. Yep. All right. All right.